2. Focus. Focus. We are looking at graphing polynomial
It's going to be a long class.
This entire section is just graphing. There's no word problems. There's no additional concepts. It's just the graphing ability. There's only 3 examples. And then we do what's called the intermediate value theorem, which is very short and sweet. And then we will be done with 4.2. Let's look at the very first one. This slide right here is summarizing what we talked about yesterday, that if you have a degree in polynomial, that means there are at most n zeros, which is another word for solutions, which is another word for x-intercepts. That's how many times it's going to cross the x-axis. It doesn't mean it will cross that many times in total, it just means it could be up to that many times. So for instance, if you were to graph, say, a quadratic, that's degree 2. But then you go to your graph and you graph it, and it's crossing the x-axis 6 times, something's wrong. A quadratic cannot cross the x-axis 6 times. So you use this as kind of like a way to calibrate how many curves there should be. Which brings us to the next part. There is a pattern with polynomial functions. If it's degree n, then it's n minus 1 curves or turning points. And the way to remember this, don't try to memorize it. Come back to what you know about quadratics. They're degree 2, but they only have the 1 curve. So that's what you remember, because you all know quadratics, you know parabolas. You don't necessarily try to memorize, okay, curves, n minus 1. Don't do that, because then you're losing the connection between the math and the graph. All right, let's dive right in.
Okay.
Graph this polynomial function without your graphing calculator. Now, I say without the calculator, we will use it for computation, but we are not going to type it in y equals and just copy the picture. The first part, so I have it broken down by 4 steps, okay? Don't write big here. I don't know if you need an idea, but if you can see how much writing, so don't write big. All right, so step 1, you have the, can y'all see that if I'm writing like this with it that thin? Okay. All right, so step 1 is the leading term. What is the leading term of this polynomial? The whole thing, tell me. Negative 2x to the 4th. Okay, there's 2 takeaways here, just by looking at that leading term. It's, yes, very good. It's an even degree, which means same in behavior. So that's going to be like a quadratic. It's either both up or both down. Because it's negative, it's both down. And how many possible curves will it have in the middle? 3. 3, right? It'll cross the x-axis up to 4 times, but the curves. So what I usually do is I draw the end behavior to say to myself, okay, it's definitely shooting down. And then I just usually do this, and then sometimes I make a note 3 curves. That didn't write. Curves. See. This is not writing.
What does that say?
I'm trying. Hold on. It's supposed to say 3 curves. There you go. It's going to have 3 curves. I don't try to make it perfect right there, though. That's why I just make a note. 3 curves. Something's going on in the middle. All right, that's the leading term. Next part. Let's find where it's actually crossing the x-axis, which is called the zeros, which means solve it. You're going to solve it. You've got to learn how to solve these. There are, here's where you've got to know the algebra 2 behind it. How many terms are in this polynomial total? There's only 2. Does it look like a difference of squares? No. So if there's only 2 terms and it's not a difference of squares, look and see if there's a GCF. And there is. What's the GCF?
X squared.
X
Cubed. Sorry.
X cubed. And I would probably pull, what do you think I'm going to pull?
The negative.
I'm going to pull a negative because I can't stand for the leading term to be negative. That doesn't matter if you pull a negative or not. It's not going to change your answer. So what I'm going to do is set the whole thing equal to 0. And now I'm going to recognize the way I'm solving this. There's only 2 terms here. It's not a difference of squares, so I'm pulling a GCF to the front. I'm going to pull negative x cubed to the front. Now you're going to write what's left by just dividing it in your head. I'd be left with 2x minus 3. Right? Okay, now you have something times something equals 0, which means that one or both of those things has to be 0 for that to be true. So we just take them both and set them equal to 0. So negative x cubed equals 0, 2x minus 3 equals 0. Solve. Don't let the negative x cubed scare you. Yes, it is 0. You're going to get rid of the negative. Then you're going to cube root. I'll change color so you can see that. I'm cube rooting. And the cube root of 0 is 0. Now, here's a little bit of the new stuff that you learned from from section 4.1. This 0, and I don't mean that by the number 0, I mean because it's a solution. This 0 here came from what factor? Negative x cubed, right? Which means how many x's were there? So this is a repeated 0 with multiplicity 3. Yes, it's going to do that. So we're going to say with, and I'm abbreviating, MULT 3. It has multiplicity 3 because it came from an expression that was x cubed. Now this right here is x to the first power, so there's no you could say multiplicity 1, but that's kind of like redundant or what is it, goes without saying. But graphing 3 over 2 might be a challenge, so I would recommend changing that to the equivalent decimal so that you know when you go to graph it where to put it. And we can, just to be consistent with what we're talking about, we'll say with multiplicity 1. Because it came from an expression that was x to the first power. But that doesn't mean anything when we go to graph. Anything special. Alright, so what we have so far is that it is opening down, it's got 3 curves, it's crossing at 0 and 1.5. I'm going to go ahead and put 0 and 1.5 on my graph. Now what you're going to find is a direct relationship to what you just found, the zeros. Now you're going to write them as x-intercepts. We're going to say the x-intercepts are, now don't get confused here, you just found them. We found it to be 0, 0, and we found it to be 1.50. Right? The 0, 0 had a multiplicity of 3, so I'm going to say times 3 and then times 1, which is my little note, like, okay, when you go to graph this and you hit 0, 0, I'm going to have to do something funny here. had a multiplicity of here. I'm just kind of bringing that info down so I don't forget. Now let's also find the y-intercept, which is my favorite to find because all you do is what?
Graph.
You plug 0 in for x. If you need to make a note of how to get that, I would write it underneath.
Is it just gonna be 0?
It is, yeah. If you ever come up with a 0 that is, this is redundant, if your 0 solution is 0, the number, then your y-intercept is 0 as well. No polynomial has multiple y-intercepts, and that's because it would not be a function if it did. Okay, so we know the x-intercept, we know the y-intercept, we know the direction it is going to run off the graph. Now what we need is an idea of where it's at in between those x-intercepts and y-intercepts. Here's where I suggest drawing a number line. Draw a long number line. On your number line, put your zeros that you've already found. We found 0. I'm going to put 1 here, 2 here, and then I'm going to put 1.5 right there. Those are the zeros I've already found. So this is where the graph is cutting the x-axis into sections. Watch this, and I'm going to erase it. You've got a section to the left of 0. You've got a section in between, and then you have a section to the right. See that? What we need to know is, where's the graph in the left section, the middle section, the right section? So what we're going to do is test points. You can test any point you want, but y'all heard me say this. I like to think smarter, not harder. I'm not going to come over here to -10 and plug -10 in. What number do you think I'm going to plug in? -1, right here to the left of 0. I'm not going to plug in 0.5 or 0.75. What do you think I'm going to plug in? 1. And then right here, I'm definitely going to plug in 2. I don't want to plug in 5 or 7 or 8. You always want to pick easier numbers to calculate so that you don't run into mistakes typing it in. And you want to pick numbers that are really, really close to the zeros because that's where the turning activity is happening. Okay? And remember, we already know that this one right here is times 3. We already know something's happening here. So we definitely need some idea of what's going on in between. All right. So this would be step 4, where you are testing other points. And this is where you get to pick what points you're going to test. I'm going to test -1, 1, and 2. So I'm going to find h of -1, h of 1, and h of 2. So go to the top of the problem, type your function in, and evaluate -1, 1, and 2. Stay focused for me.
What is it?
Trying to trip me, or was that an accident?
They knew the twins.
Mm-hmm.
Yes.
I get workman's comp if the student trips me and I get
I did.
burned.
I can tell.
Where's,
I'm not even here.
what'd you get for -1? What? Yeah, I got
What was the answer?
-5. What'd you get for 1? And 2?
Oh, I got -5.
So what you just found are 3 new points. I'm going to just draw one big arrow to say that if you don't recognize those as points in this notation, then change it to this notation. So when you go to graph, you know what the graph has to pass through. Those are your extra points. So I'm going to put them on my graph. I got -1, -5, 1, 1, 2, -8. The last step is to now connect the dots. Please do not do this. Please don't do that. That looks like a quadratic. First of all, go back up here to what you know. You know it's shooting down. So find the 2 outermost points and go ahead and shoot the graph down through them. You can see that this is an outer point and this is the outermost point. Right? Now we've got to connect through those points. Which one did we say had a multiplicity? This one was, and when I say times 3, that means the multiplicity of 3. It doesn't mean multiply anything by 3. So I know that that's odd. Remember, mini Saturday Night Fever. So as it's coming up to it, it's going to do a mini Saturday Night Fever, and then the rest of these were normal. See it? You need to, you can put SNF for Saturday Night Fever. So when it gets to that 0, 0 point, it's going to be a little mini cubic function. So it'll go to it and kind of lay across before it crosses over. Don't just shoot straight through it. Now it'd be really cool for you to see in your calculator and compare your pictures. So go type it in y equals, then hit zoom 6, and you'll see what it looks like. But it's pretty dark. Not bad for by hand. Well, the very first one always takes longer. Because I'm showing you all the.
You know the word.
I'm pretty sure I just put all of them. Oh, your plot's on. Turn your plot off. Arrow up. And hit enter. Now turn it off. Now, okay. If your plots are on, the word plot will be in black. You can turn it off by arrowing up and just hitting enter. Finding the pattern.
That didn't feel good.
Okay, go to the next example.
Alright, where's the stress ball?
The next example, the only difference is that this problem is not a GCF to solve. It's a by grouping.
Are you yelling at your class president? It's a terrible word.
You said what?
What? You just threw out 3 letters, wasn't you? Alright. First, copy the lead term down and analyze it. Don't holler it out, okay? I want to see if you can do this. Second, find the zeros by actually solving it. And I've already told you, because there's 4 terms here, you're going to check if it'll solve by grouping. Group the first 2, group the last 2, back to the GCF. Then you've got where after you solve it, you list your x-intercepts and you list your y-intercept. Then you find your extra points and test. So try it, because I would like to go over the answers together. Some elderberry, stay away from sugar, lots of water. Sugar kills the immune system. No, I already knew that. Sugar cripples your immune system. Think about it. Cold and flu season is during the most unhealthiest months because of all the desserts, candies, Halloween, Thanksgiving, Christmas.
No, Garrett.
Kills your immune system.
There's still stuff on my desk. Here's a thief.
Bro pointed a
I shoot!
That was fake.
That was like, oh.
That was
Over
fake.
you? He did sneeze into his arm. I know he into his arm. But it's all good. He's just a loud sneezer. Alright, thank you for working.
I'm sorry.
What is the leading term here?
2x studies.
Okay.
Wow.
You're looking at two things with the leading term. You're looking at the degree to determine the end behavior, and then you're looking at the sign of that leading coefficient. So it's positive and it's odd. So that's Saturday Night Fever. And because it's degree 3, it is a strict, like, Saturday Night Fever. You know, there's no extra curves in the middle. It is Saturday Night Fever. It's a cubic function. Now we're going to find the zeros. There are 4 terms here.
That's union.
There's 4 terms, so we're going to look and see if it factors by grouping. Group the first 2. Remember when you group to make sure those parentheses in the middle are touching so that the sign of the third term sticks out like a sore thumb, because that will be the sign of the GCF that you pull out of the expression. Alright, GCF here, x squared. I'd be left with x plus, not x, 2x plus 1, right? What's the GCF here? -4. It's always the sign of that term. That's why I look at it. Pay attention to that sign. And then I'd be left with 2x plus 1. Now my GCF is 2x plus 1. And then I'm left with
Callie, I told you not to say anything. You said something.
No!
You're fine, I promise. Did you check in through the front, by the way?
Hello, Ray.
If she yells at you from across the room.
Did they send it?
She's already yelled at me today.
Oh,
Already?
that's right.
Oh, yeah.
Yes, you did.
All
Alright.
Food war.
Pull 2x plus 1, and then you have x squared minus 4. Remember, the whole point here is to solve. Now have it something times something equals 0. So set each of them equal to 0 and solve.
You'd be breaking.
He said it'd be broken.
Breaking.
What's the square root of 4 when you're solving?
Plus or minus 2.
There you go.
It is
Let me just
Stop.
No. Why are you torching?
And instead of like solving it as
Well,
x
it's
squared
he
minus
doesn't
4
really
can
wanna
be
know.
separated.
He's generally
This
nice.
is the
He's literally torching your shit.
x plus 2
Oh,
is
yeah.
Broke it in the
Yeah.
first place.
You'll get
Yeah.
the same
Do
answer.
anything in the car.
Some people,
Let me just.
hey, y'all, some people don't see the difference of squares because they forget that that exists in the polynomial. So that's perfectly fine. You'll get the right answer.
It's from my
In
steroids.
fact, if you go the route of the difference of squares, you don't have to worry about forgetting the plus or minus because you're going to end up with both. If you go the route of solving by square roots, you have to remember plus or minus right there, or you've lost one of the zeros. Now we're going to write it as actual coordinate points. I like to make the fractions as clean decimals so that when I go to graph, I know exactly what it looks like. How do I find the y-intercept? You're just plugging x equals 0 in to the original function. Plug x equals 0 in to the original. And you get that it's what? Negative 4. Now let's plot these.
It's just the last one.
So we've got negative a half. We've got 2, 0, negative 2, 0, and then 0, negative 4. And then now, extra points. Let's draw a number line. And you don't really have to draw the number line. You could just look right over here and say to yourself, okay, I got to pick a number from here, pick a number from here, here, and here. So you could do that instead of drawing the number line. I just do the number line so that for anyone that needs that like structure to know what to put. Alright, so we have negative 2, let's put negative 1, 0, so negative 1, negative a half is right here. We have 1, 2. So now I'm going to pick my test points. What do you think I'm going to pick to the left of negative 2? Yeah. What about between 0 point negative a half and negative 2? What do you think I'm
Negative
going
1. What'd you say?
What'd you say?
No.
Okay, yeah, have fun with that. I'm going to do this one. I'm going to do negative 1. You do that. You do you, boo. I'm going to do this. I'm going to do negative 1. I don't know. I mean, yeah, you can. What do you think I'm going to pick between negative a half and 2?
1.5.
Okay. I'm gonna pick 0. Is it okay to
You what you?
You can.
We already have the 0.
do we?
Yeah.
Oh yeah.
What
are we doing?
I would have picked 0 and then I would remember that's the y-intercept. Yeah, never mind. That's the y-intercept. Let me put that right there. Y-intercept. And then on the other side of 2,
3.
What are we finding?
Extra point.
She lost me 20 minutes.
Why are we finding other points in the graph?
To find the other points.
Test it, right?
Oh, to make sure. Listen here, buddy.
who got lost?
All.
But it's not. I knew.
No, it's fine. It's fine.
It's not okay.
Oh. Well.
Yep.
I'm not the one chirping. Hey, miss.
Where did I lose you?
Holcombe.
Did you pinpoint?
Yeah, finding
Well, I need to know where the graph. I can't just come over here and do this. Like I don't know where the graph is. So this is the equivalent of, hey, here's a line graphic. Pick some numbers, plug it in, plot them. But it's strategic. You want to pick numbers that are near what you've already plotted because that's where those curves are happening, right? So I'm picking numbers to the left of this, in between, to the right.
And not 0.
Well, I don't want to pick 0 because I already know it. You can, but you're going to get -4 because we already did it, right?
Do we have to test one after?
No, not necessarily. It's just to be more accurate, you would want to know, like sometimes they shoot straight down and then sometimes they kind of go out. So that would be the only difference there. Oh my word, this is 4.2 and you have to go through 4.6. Save that question when we get through 4.6. All right. So I'm going to test. This is me just summarizing all of it. I'm going to test -3, -1, 1, and 3. So f of -3, f of -1, f of 1, and f of 3. Callie, where did I lose you? Was it that also that same spot?
I understand this.
Okay. This is just solving it. So this was us solving it to figure out where it's crossing the x-axis. Since there's 4 terms, we solved by grouping. Here there was only 2. So we pulled the GCF out. It's only the second problem, so we have one more to do. So me?
Stay in your lane.
Tried to stay in each chair, but you know.
I have a pretty good excuse. So. Could have offered to go. You nice?
Amy, get out of the chair.
Don't you dare finish that sentence.
What?
There's a lot of expected life.
What does that mean?
Squirrel. What'd you get? Did you type it in?
No.
Oh, okay.
I missed
You have to do all of them?
I got the same answers as you.
Why is there 4?
Wait, can I just like put the function in while you just go to the
The
table?
negative
Hey,
negative one,
teacher.
the answer is 3. And positive one, the answer is -9. That's the only one that I did. I'm sorry.
The first one is -5.
Holy crap.
45.
I was like 39. You have to do 3. You don't have to. You just said it was fine. You can even plot that.
Blocking the line. What is she writing?
So as you're doing the test points, you may come across points on the outside that you cannot plot because the graph doesn't go that far. That's okay. That just gives you an idea of how steep the line would be to shoot in that direction. So now we're ready to put it together. You should embrace the fact that these zeros have what multiplicity? Since this is 2 answers from an x squared, it's just a 1 gap. If it was x squared and you came to a single number, it would be 2 gap. So I'm glad you mentioned that. Any of them come from x cubed?
Jackson, I got.
Don't come up here.
I wonder
No,
get a
it's always
flashlight?
right here at the back.
Just walk out.
This is linear.
Facts.
He's not gonna crap, is he?
No.
He hates his class.
That's still be positive, negative.
Knocking stuff over, are we?
I'm trying to give you things
Can I knock myself
so
over?
you have to take
Someone else can. If you try
like
to run up
if
for me.
it's 0.
Flip.
I mean, I did
If
it on
it's
accident on
just
Friday.
x squared, right? So because the multiplicity is 1 on our zeros, we have no special tweak tweaking to do when we hit the x-axis.
Let's do our little line.
So it is like an S curve. You are just curving in the direction of the points. I would suggest starting on the left and then working your way to the right. Don't forget the direction the graph should end. It's going in what directions?
Up.
The left is going to go down and the right is going to go
Up.
up.
Hooray.
And then so now right here, technically we don't really know, like does this go stop. Does this go
Nice.
like that? Or does it go like this? Like we don't know that. This is just to get a sketch. If you wanted to know how high does this go or how low does this go, you would have to pick x values right there in that area, like right here, -1 or 1. Oh yeah, I haven't plotted them. I just haven't grabbed those two right there. -1, 3. 1, -9. But now you can see the purpose behind getting those points, because I just showed you. Like, I didn't know what it was doing right there. So now I can graph my S curve. And I'd like you to try the next one. And it is in standard form at the beginning so that you know what the leading term is. But then I put it in factor form for you because it does not factor by grouping. So this is the standard form. This is the factored form. The standard form is there to help you see what the leading term is. The factored form is there to help you solve it.
So it's basically less work.
You gonna give us one on the exam? One that's not good and one's not.
If I give you one not factored, it will factor, whether by GCF or by grouping. I wouldn't give you one that doesn't factor either of those ways. Which means a mini parabola when you hit that 0.
What?
Hurt someone. I have 1,200 emails.
Quads are the little 7.
Actually, not at least.
Actually, factor.
Hold on.
Feel very bonkers.
Okay, we are looking at this. What's the lead term from standard form?
X to the 4th power.
Okay, so it's positive, it's
Yes,
even,
where?
so it's a touchdown,
Yes.
right? With some terms, some curves in the middle. How many curves in the middle? Up to 3. All right, zeros. This is where you want the factor form. What's the 0 out of this one right here? -1. What about here? What? With multiplicity 2. And then what about here? As coordinate points? What's the y-intercept? To go and graph it, I need a few extra points to see what's going on. I've got -1. And you can't pick 0. We've already talked about 0 is the y-intercept. What would I pick to the left of -1?
-2.
All right, what about between -1 and 2?
1.
Okay. Here's pick 0.5, that's fine. What about between 2 and 4?
3.
What about after?
5.
So I'm going to test x equals -2, 1, 3, and 5.
Yeah, you said HF.
Well, it's function.
Okay, does it matter? Because I couldn't really.
Oh, no, it doesn't matter. I just looked at the example and copied the letter that's in the example. No, it doesn't.
Wait.
-2, did you get 96?
Yes.
1, what'd you get?
-6.
3
Negative.
and 5. Okay, so we can't graph this or this, but it's okay. You know, we found it, we know it's shooting off the graph, but we can graph the 1 and the 3. All right, so plot your zeros.
He's correct.
-16 is shooting off the graph. I'm just going to come down here and write that this is 0, -16. I don't have any room, right? Which one had a multiplicity that I need to worry about? 2 has a multiplicity of 2, so I'm going to come right here and do times 2 to remind me that when I hit that point, I need to make a mini parabola because it's even, right? And now, depending on the direction you're coming at it from, if you're coming from below to it, you're going to bounce off and go back down. If you're above it and you're coming to it, you're going to bounce back up. All right, I want the points.
Yo, the tea is so warm.
So 1, 6,
You've been there laughing long.
3,
You laughed pure air.
all right. Okay, it's opening up. This is my outermost point, and I can see now that everything is easy peasy except for that one right there. I do need to try to hit this, right? So don't shoot to that one. Now you've cut the y-axis, y-intercept. So you got to come down here and hit this. Now coming up to that one that I mentioned, so I'm going to bounce off of it and come back.
Why didn't we use the -2 and 5? They're like big numbers.
Then don't use them.
It's just a 5 points here.
You didn't know that they were gonna be.
When I plugged that in, I had no clue where the graph was going to end up.
Oh, we might. Oh, it was just.
We get just a.
All right.
Stop putting that in
The
the
last 2 slides have the same topic. It's called the intermediate value theorem. I'm going to leave this picture up right here, though, to give you an idea of this. The intermediate value, here's where you really have to understand graphs. I hope you're locked in, because this is one of those you should not get this wrong at all. Because all it has to do with is the sign and the number. The intermediate value theorem is, what if I don't necessarily want to graph the whole thing? What if I just want to get an idea of if the graph is above the x-axis or below the x-axis? Well, what is the only thing I need to know to determine if I'm above or below? Sine of not necessarily, but the sign of the y value, right? You with me? If the y value is positive, it's above. If the y value is negative, it's below. If, here's the intermediate value theorem. If a y value is positive and the y value like right next to it, or I'm sorry, the very next point has a y value that's negative, what does that tell you the graph just did? It crossed the x-axis, which means what exists? An x-intercept, or a zero, or a solution. So the intermediate value theorem is saying if you know that the sign of a y value is positive, and then all of a sudden the sign of a y value is negative, like right there near each other, the graph is crossing the x-axis and there is a zero in between those 2 points. That's the intermediate value theorem, okay? So I said that, now I'll turn to the slide, because now you can see, here's where they're saying, for instance, if you plugged in A and you got a positive number, that means the graph's above the x-axis. If you plug in B and you got a negative number, that means the graph is below the x-axis, which means the graph is crossing the x-axis, which means there's a zero in there somewhere, right? Try it one more time. If I plug a number in and I get positive, it's above it. If I plug a number in and I get negative, it's below it. The curve, remember, polynomials are continuous. So it was above it, now it's below it. You've just crossed over the x-axis, which means now there's an x-intercept somewhere in between.
That's just telling you you have to solve it.
It's just telling you where they are. We're not actually solving it. It's just saying, hey, yeah, there's one here. That's all it's saying. This is if I didn't want to solve it. But I just wanted to get an idea of where they are. Here we go. Using the intermediate value theorem, determine, if possible, whether the function has a real zero, meaning an x-intercept between A and B. Now, I will agree that, or I will say that the way that this is formatted is not user-friendly, because when you first look at it, it's a lot. This is the actual function here, and then there's a break, and then they say check A is -4, check B is -2. Here's the actual function. Now they're saying check A is -1, B is 3. This is not even a polynomial, but we'll go with it. It's a function, and then there's a function. You'll notice that the two functions are the same in the first two and the second two. All right, how do you check it? Yeah, you plug it in. So I'm going to put A. I'm going to plug in -4. For B, I'm going to plug in, or sorry, there's a lot of numbers here. Plug it in. So plug it in. Tell me what you get. Plug -4 into the function for A. No, I didn't get that. Try it again. Put -4 in parentheses. -6x. Yeah, I got -24. Make sure you get -24. Did you get -24? Okay, now plug in -2. You get 8. What did it do?
Crossed.
This is negative and this is positive. So it is crossing the x-axis. It is crossing the x-axis. By the way, this is how you write there exists. That's shorthand notation for there exists. There exists an x-intercept between -4 and -2. Because it's definitely crossing. Because at -4 it's below, and then at -2 it's above, so it had to cross.
That's it.
We're not finding the zero, we're just saying there is one. Huh? When you go to a graph polynomial, this is telling you
What a conversation we've had.
where the x-intercept
He needs to sit up here more often.
So like when
He talks about parasites and foot.
his
His back?
I plugged in -2, I got 96. That's positive. When I plugged in 1, I got -6. So that tells me that the graph is crossing the x-axis. There's a 0 between
Hey, bud.
-2 and 1.
Oh my god.
And -2
Ladies on.
and 1's right here.
Bates.
You see
He
that?
looks so upset.
So if you do that,
Suck on my neck like a
That's
dragon.
another
That's
check.
fair.
Oh, I just threw it too far.
Let's try B.
My-
Trying to hit me.
No, I was just trying to throw it to myself.
B is checking -1
Where'd he go?
and 3. In function F, in that plot function. Stay with me, please. Please stay with me. What'd you do for -1? What about 3? Yeah. What'd you get? Did you get 0? Try it again. What are the signs here? I'm putting that little orange highlight where an understood plus sign is to say, hey, it's positive. So this is positive and this is positive, which tells me the graph is staying above, which means that we don't know. Wait a minute, it cannot be determined. There's not enough info. You can't necessarily say no, there's no 0. It's just that we don't have enough to say it's real 0. There could be an imaginary 0.
You've been out the door for a couple years then.